Hello everyone, this is Kiran from IT department GRIT. So today I am here to show you our project which is based on IoT. The title of the project is Face Threat Protection Innovative Smart Cap. Going into the abstract, being immune to new virus and infections which are continuously evolving every 10 years is a difficult task for humanity. One of the safety measures used is wearing a face mask. Wearing a mask helps you to maintain the social distance when interacting with others so that the distance won't spread. However, usage of long face masks for longer hours will lead to different breathing issues including suffocation. In order to help the people to cope up with the discomfort in public places, we aim to provide an automated face protection shield using Arduino that turns on the face mask and turn it off as the user approaches the other person. After sensing the motion, the device determines how far away a living thing is from it. The next step is to determine if the individual is secure from contact with other people. Then the data is uploaded to the cloud. Once the data is uploaded, we can easily determine the distance at which the person first made contact by analyzing the data which is stored in the cloud. Existing systems. In existing systems, it was the basic model that notified the user with a buzzer sound. Whenever a person approaches the user, this model works good. It works for the social distance monitoring. Still, the user had to wear the shield for the same duration, which is the drawback of this existing system. The next one is the model where the shield can be turned once when the other person enters into the specified radius. It partially solves the problem of wearing the mask for a long time. Our proposal. We create a headgear with a face shield that functions in line with sensor data. The PI sensor will particularly detect the presence of humans and animals by heat signatures which are emitted by them, and the ultrasonic sensor will measure the distance. When the device detects a person nearby, the servo motor will cover the user face with a face shield according to the proposed model. The real-time database will be stored will be storing the data of sensor for the future usage. Now we shall discuss the methodology by using the activity diagram, use case diagram, sequence diagram, and system architecture. Going into the activity diagram, we see that whenever a person arrives, the sensor will detect the environmental changes. It reads the values from the environment and it gives to the ESP32 system, which is the Arduino board ESP32. Then the ESP32 will check the following conditions. If the following conditions satisfy, then it allows its statements to execute, and this loop will be iterated till the person is not in contact with the user. Use case diagram. Here we can see that there is a person and a system which are interconnected to each other. Whenever a user approaches a person, it the system will detect the motion and measures the distance. The values which are read by the system will be checked whether the condition is satisfied or not. If the conditions are satisfied in which the user is unsafe, then the motion will be enabled. If not, the motion will be offed. Again, the data will be validated from the person by knowing the distance and the motion detection. This data will be saved in the cloud, and the cloud data can be accessed through the mobile app by the user from the system. Sequence diagram. So in this diagram, the person who is in contact with the user uh, will try to make an approach with the user. So the sensors will measure the distance and also detect the motion. The ESP32 will validate the person presence. It, it checks the condition whether the person is unsafe or not. If he is unsafe, then the motor status will enable on. Again, the ESP32 will check the persons available. If the person is available, then it again measures the distance and detects the motion. After that, the ESP32 will again validate the person identity. Then, if the user is safe, then the motor status will turn off. So it will indicate the message to the user that the person is not available. System architecture. By using the system architecture diagram, we could easily understand, and it is also like a lucid diagram. Here the person who is in contact with the user will take the from which the PR and the ultrasonic will take the readings, and it will send it to the Arduino board, which is the ESP32 Wi-Fi enabled board, where the Wi-Fi enabled ESP32 board will check the conditions. If the user is unsafe, then the servo motor execute the statements from which the face shield will be enabled, and sta- uh, and uh, this data will be saved in the cloud, which will be further accessed in the future usage. Now, this is a smart cap implementation where we could find that there is a attachments of different sensors and components on this cap. Here we could see that there is a ultrasonic sensor, PIR sensor, and the ESP32 board which is attached, and in the front of the cap we could see a servo motor which is attached to the face mask. So let us see the code implementation of the smart cap. Here in this Arduino tool, we have written the code for the smart cap implementation. It is written in the C language. Now after that, we are going to verify by compiling it. We have done the compiling of the code. Then we are going to dump this code inside the ESP32 board. Now the code which is dumped into the ESP32 will be executed. Here we can see that the attachments which are attached to the smart cap. So now it is connected to the laptop. We could see that there is a serial monitor which shows about the motor status and also the distance values and PR values. It randomly changes its data, and this data is saved in the database which is Firebase. Here it tells about the distance and the motor status. Also, after knowing this database in Fire, after having this data, so after execution of the code, we are going to demonstrate our model. So in this the user is sitting, and when a person is approaching, the face shield is on enabled, and when the person goes away, the face shield will be off, which gets back to its normal position. So again we are demonstrating with the help of our team members. So the person who is will be approaching a specified radius. uh, In the results, we are going to see the Firebase results, in which the data is stored in the Firebase, where the distance and the motor status are available. In the Blink, which is a mobile app which helps for the user to determine the ultrasonic and servo motor values, also the PR values. Conclusion: we have discussed the use of smart caps for the prevention of contagious diseases. We use ultrasonic and PR sensors for which are crucial for detecting any variable nearby. Therefore, using the sensor, we use a servometer to mechanism to provide with the protection. By talking to one another, we use this type of technology to prevent the spread of harmful diseases like airborne illness. Finally, we think that by safeguarding against viruses and airborne diseases, our suggested concept for preventing contagious from harmful diseases can be used at an early stage. Our team, our project guide is Rajesh Shekhar, Professor. Our group members are Seth Dilip, Bande Rakesh, Kiran Kumar. Thank you.